Okay, Demet Hocam, we're good to go.
Okay. Uh, okay. Dear students, dear academicians, and dear faculty members and participants, you are all welcome to our ArchiDesign Timber Talks series. This is our second meeting for spring semester. This evening, we have a valuable guest speaker from Vienna, Austria, Mr. Oliver Sterl. Again, I want to say welcome to Oliver. And I would like to introduce architect Oliver Sterl to you. He is a distinguished architect and currently serves as the partner and managing director of Rüdiger Lainer and partner office. With an impressive portfolio of major buildings, Sterl has played a pivotal role as a project manager and collaborator alongside Rüdiger Lainer. His notable projects include the Cineplexx Center in Salzburg, 2001, the extension of Favoritenstraße in Vienna, 2005, and the Chamber of Commerce in Pölten, 2005. Sterl has also made significant contributions to architectural endeavors such as the housing complex and kindergarten, Haus mit Veranden in Vienna, the apartment and old people residence in Döbling, Vienna, 2012, and various apartment buildings throughout Vienna, 2014. Sterl has displayed a strong commitment to architectural excellence and innovation. He has been involved in notable projects such as the extension of Schottenring 19 in Vienna, the residential project Sonnwend-Quartier, the apartment building and service apartments in Quartier Belvedere Central 2018, and the pioneering timber high-rise HoHo Wien in 2014. We met at this project presentation 4 years ago in Istanbul, and Sterl also contributed to the housing complex and hotel office building, Biotope City 2020, and the upcoming MGC High Rise 2013. He is actively engaged in lecturing and participating in numerous juries, both in Australia and abroad. Now he is with us and sharing his knowledge. He will share his knowledge about high-rise timber buildings and sustainability of the cities. This evening title is High-Rise Timber Buildings and Sustainability of the Cities. The desk is yours, Oliver. Thank you.
Thank you, Demet, and good evening to everybody. So, unfortunately, I had a vocal cord infection last week and my voice was damaged until yesterday. I will try to give this talk in person, but I think you can relax. Should my voice fail, we have a plan B. A colleague of mine, he made a video of this lesson, and then we can play it in case if I would fail, but I won't. So. The topic of today's lecture is high-rise timber buildings and the sustainability of cities. So our office has some experience in these areas. On one hand, we are urban planners with a focus on sustainability, urban development. And on the other hand, in 2016, we have built the first wooden skyscraper in the world, which is over 80 meters high. But today I'm going to stretch the arc a little bit wider to implement those contents for a successfully building process with wood materials. The task is on wood materials. We need a paradigm shift and the departure from familiar parts. As you can see on the sheet, we have to think differently. We have to act differently, and we have, of course, to focus differently. This I will present you today by the means of 3 examples with different sizes. We have a 40 meter high wooden skyscraper, which is called the HoHo, the Holzhochhaus wooden skyscraper in Vienna. We have a 3-story row house and a 5-story ensemble of 3 wooden buildings. Architecture is a team sport, and this is part of our team. We currently have 18 employees working for us. The office is situated right in the heart of Vienna. And the office was founded some 40 years ago by Rüdiger Lainer in 1985. And since almost 20 years, since 2005, I'm partner in the office and managing director of RLP. The range of our work spans from urban development to renovations to new constructions, a lot of office and residential buildings, especially subsidized housing, which we make in Vienna and around the area of Vienna. What you can see here is a sheet with examples of our buildings. I will not go into details today. We don't have enough time for this, but I will focus on the wood and wood hybrid constructions. So first of all, I have to tell you, nobody is born as a timber architect, and neither are we. So to be honest, it took us some time and some coincidences to gain experience in this field. If you want, so we came across timber construction more or less by accident, somehow a bit like the virgin to the child. It started with an urbanistic project. So in 2011, we won an urban planning competition for the Seepark-Quartier. This is a part of the urban development area Lakeside Aspern, which I will talk about later a little bit, where the HoHo is situated. So while presenting this project before the jury, we were asked what ideas we had for a lighthouse project to create a unique image of the district. Among other ideas, we thought the first time of a wooden high-rise building. At that time, it was 2012. We weren't entirely serious about it because it was no definite project and no definite builder yet. And then, if you want so, coincidence came into play. A year later, 2013, the Austrian real estate investor Günther Kerbler, he acquired a few construction fields in this Seepark-Quartier. At this time, we negotiated with him on the planning of a high-rise building in conventional construction of concrete, steel, and glass. A year later, 2014, this investor added a Styrian company, which is called Schachner Haus, a timber construction company, to his portfolio. The public relation department of the company then asked if our idea of a wooden high-rise building could be implemented in the whole structure. And the result is the HoHo project, which you can see is the first picture on this sheet. That was the beginning of our career, if you want so, as timber architects. Since then, we have been transferring these ideas from the HoHo project to smaller and not so tall projects. In 2014, at the beginning of the planning of the HoHo project, the legal situation in Austria was that constructive timber buildings up to a maximum of 3 stories were permitted. No higher buildings in wood were allowed. A high-rise wooden building with a height of 48 meters, as you can see it here, and around 24 stories was then and is even now definitely much too far outside of this regulation. So the concern of the building authority, not only, but especially was the fire protection regulations. Therefore, before we started the planning, the object, it was necessary to develop a strategy on how to communicate and enforce such a project in the mind of the decision makers. The base for these considerations was the Viennese Building Code. More precisely, it's the paragraph 2 of the Viennese Building Technology Guideline. It's a horror word. This is the favorite paragraph of all architects, and of course, it's a favorite paragraph of mine too, because it says that it is possible to obtain a building permit for components that do not meet the normative or legal requirements. You can do this if you can prove that you fulfill the protection guidelines or the protection goals that lead to those guidelines. And this is exactly what we have done. We created a discussion about the protection goals. Here you can see a chart. This is where everything started. On the right-hand side of the sheet, you see all the legal regulations. On the left side, the protection goals on which those regulations are based are listed. And in the middle, you see the set of measures we make, or we told them we can achieve the protection goals in a wooden high-rise building. So we went to the building authority and first showed this chart instead of any sketch of the building. At the first meeting, we estimated that the chances of getting kicked out was about 80%, and the possibility of achieving the target was, we would say, less than 20%. But after getting out of the meeting room, we were very, very optimistic that our chances had now increased massively. And after a few more meetings, we saw a light at the end of the tunnel. On a few more meetings later, we were convinced that there was a basic possibility for the approval of an 84-meter wooden skyscraper. And this was the time when we really did start the planning of the building. So we had regular meetings with the building authorities during which our ideas were systematically checked for stability and for fire protection. Anytime we went home from these meetings and worked on the solutions of these issues. So if you want, so we did our homework. And until there were no more questions left and the building was ready for approval. But in addition to that, what we call institutional intelligence, the second approach was to ask the questions, how simple can you design a high-rise wooden building in an urban environment? The motto was, keep it smart and simple. And the project is in smart and simple in some ways. We have a very simple project in a very complex urban space. I will tell you later on about the Quartier. The building has load-bearing exterior walls and load-bearing cores. And in between, you have a layer, which is mostly 7.5 meters deep, where you can bring in every usage very easily, and you can change it very easily. We have a simple construction. The object is a wood hybrid building. So we have a core made of reinforced concrete, and attached to that, we have a wooden structure where all the usages are in there. So the task was that each material is used in such a way that you can get an optimally fit of the requirements out of it. We have a very easy communications. From the beginning on, we had regular meetings with the building authorities to discuss all security aspects of our design. Because of this, we could get a building permission, and so we could build the BAU. But the most important thing for us is that the building is very simple to understand for everybody. This is a house where the material wood is visible. You can see it, you can smell it, you can touch it. You just feel that you're in a wooden house if you go in there. And this is the object. It contains of two buildings, a high one, which is 40, 57, and 84 meters high, which is called HoHo Wien, and a smaller one, which is called HoHo Next, which is 13 and 23 meters high. So they're connected underneath with garage and technic areas. The project is situated in the Seestadt Aspern. This is a 240 hectare wide urban development area in the northeast of the city of Vienna. When this will be finished, about 20,000 people will live there and work there. I think about 13,000 are already moved in this area. The master plan was created by the Swedish colleague Tovat, and the concept is has a lake in the center, as you can see here on bottom right, and around it you have a loop, and then you have various construction sites which are built since 2005, since Tovat won this competition. And one of the construction sites is in the south of the lake. Our office won the competition in 2011. As you can see here, it's 11 hectares wide. And the idea was to develop a piece of land along a sequence of plazas, which we call transversale. This is the main axis, and this is nothing more or less than a sequence of plazas with different urban qualities and different urban situations. You can think about it like a chain necklace. The main axis is connected to the nature in the north, the lake, and to denser areas in the south, with beneath axis we call capillar. And in between you have different building sites which are developed since now. What you can see here is not the master plan. This is one of 20 test designs, so we can think about what would be the best master plan to get for this area, because it was very complicating and a very complex thing to have what we call urban partition, where we just made some rules for each building fields. So for this Seepark district and the surrounding districts, what we made is a high tower study. With all the twists and shifts and proportions and heights of the buildings, of the towers, we create a unique skyline to the lake. And this was very important for this very flat area in Vienna. So you have some points of orientation and identification. This is a surplus for everybody who is using this area. And one of the buildings, as you can see here in the middle, this is our HoHo building. So the HoHo building is a European skyscraper. This means it acts and interacts with its surrounding. It's part of the urban context, which we call Seepark Quartier. Because of the situation at the end stop of the subway station U2, we have two totally different urban situations. First of all, if you come out of the subway station U2, you enter the plaza. And this plaza is not only the plaza in front of our building. This plaza is the entrance to the Seestadt. This is the entrance to the Seepark Quartier. And therefore, it was very important to have a mixed use building with hotel, restaurant, shops, office spaces, wellness, fitness, health, beauty, and so on, which brings 24 hours of life on this plaza. And then when you come out of this plaza, it's always important to have what we call a human scale in approaching. Therefore, we stepped down the volumes of the tower to the plaza to create a proportion where you as person can relate somehow with the height of the buildings. To it, we have a sheltering roof coming out of the first floor of the tower. This sheltering roof gives you a kind of optical line where you as a person can relate to the whole situation. So the second urban situation is to the lake. Here, everything is about orientation. Everything is about identification. Here, the building has to be high. It has to be strong. It has to be a very strong appearance. Flexibility and variability are basic of this project, of course. So we have two cores, which you can see here as magenta cores. And around this, we have a layer of free space where you can bring in every usage very easily, and you can change it very easily. With those two cores, you can divide each floor from 1 to 3 units. And the whole thing was thought from the beginning on as shell and core system. So this means the shell is fixed and the core is fixed. And we didn't know the definite users. We didn't know the definite usages which are in there. And to show the capability of this building, we draw floor plans, as you can see here, for every usage and every floor. This is a hybrid building. We have a reinforced concrete core, which is made on site. You can see it here on the right side of the sheet. To that, we have a wooden structure which is attached to that. The wooden structure is a prefab structure. So we have parallel productions processes. So you can optimize the assembling and you can minimize the building period. And you can minimize the building period also because the system is so simple. The structure is built up like a child's construction set. We have only 4 elements. So along the facade, we have a horizontal reinforced concrete beam, which is running around. This is mostly for the very, very unlikely case that some of those corner columns would collapse. On this beam, to expand to the core, we have wood concrete composite elements, which consists of 16 centimeters CLT, cross-laminated timber, and 12 centimeters of wooden slab on it. The elements are 2.40 meters wide and 7 meters deep. They're made prefab, brought to the site, then they are lifted up, put man to man, and then they are just sewed together, as you can see here and here, with very less moisture. So the whole thing would be shear stiff. This is the load-bearing system for the ceiling. The load-bearing system vertically is made of wooden columns, which are made of glued laminated timber elements. They are always 40 centimeters deep, and depending on the load they get, the width is different. So on the top floor, they have 32 centimeters wide, and on the ground floor, we have 108 centimeters wide columns. It's the logic of a Christmas tree. So this is the whole load-bearing system. The facade elements, they are 4.80 meters wide and 3.50 meters high. They're not load-bearing. They are just carrying their own weight. They come to the construction site prefab as well. Consists of 14 centimeter CLT slab and thermic isolation layer, 20 centimeters, and then curtain wall. This is the building process, as you can see here. In the pictures down, you see the construction of a wall element in the fabric of the company Handler. This was our building company. The windows came in there, they are prefab, the sunscreen is in there, the windshield is in there, and then everything comes on this construction site. And as you can see here, the column was assembled on the ground floor, then the whole thing was lifted up. And so we could more or less fix it with those needles, as you can see here, coming out of the column. The whole element was fixed. the beam was put on it, the ceiling slabs are on it, and the whole story was finished. And it took us about 1 week per part and story. So depending on the wind we had outside on the construction site. This is a detail. As you can see here, we have the reinforced concrete beam running around here, as you can see here. Then we have the columns, which are under the beam. We have the ceiling elements, which you can see here. Visible wood on the ceiling, on the beam, and on the outside wall. And then this is the outside wall element with 14 centimeters CLT, 20 centimeters of thermic isolation layer, and a curtain wall, which is made of timber in the case of the lower building and in the case of the base of the tower, and which is made as Eternit facade in the case of the top floors of the tower. So as you can see, we have visible wood, columns, walls, and ceilings are visible, not only in construction site, they are visible right now in usage as well. And this is very important for us, because if you're walking through this building, you can see this is a wooden building, you can feel it, you can touch it, you just know that you're in a wooden house. And here once again is the remote view from the lake. And if you remember the first picture I show you, everything started with a sheet, an Excel sheet, with a strategy of how to explain a building that does not fit into the building code. This way we could give the decision makers the feeling that there was no danger and it could be approved, and right now it's standing into the landscape. So we come to our second project. Now we're talking about act differently. This is a little bit sad for me, this story, but you will understand. Not everything in life works 100% perfectly, not even in the life of an architect. This example is about the fact that for the implementation of wooden buildings, you need increased care and collaboration, from the planning to the construction to the site use. Timber construction has been a successful building method for centuries. You all remember we have wooden temples that have existed for over 1,000 years. The Fugong Temple in China, for example. But if you talk about modern timber construction, you have to deal with the modern society. And this modern society has massively changed their way of life, as well as their demands and their behaviors into the buildings compared to the old times. So for this, you have to think differently and act differently. We have airtight buildings. We have higher component temperature, which is a very dangerous part if it comes to moisture. We have higher water vapor, which people release inside the building. And this requires a completely new definition of every component, every layers, and of course, of the whole wooden building. We have the technical solutions, of course, but this system just works well if everything is done correctly. But a sum of small mistakes can have very fatal consequences in such a very complex system. I would like to show you an example of this mechanism. On the base of this building, a timber high-rise residential building with around 30 residential units. this is the blue point here, is located in the north of the city center in about an 85-hectare urban development area. This was a former train station. The HoHo I was talking before is on the side of a former airplane. This is or airfield. This is the site of a former train station. The urban development concept of this area was created by a Viennese office called Sterl, and this provides for a very large central open space in the center, and the areas of this space are very dense. It's a very dense development. So here you can see our site. Our buildings, they are located in the northern part of the area. So directly connected to the park, this will be the central park, which is going from here, all the way down. This is a plot about 6,400 square meters and about 11,400 square meters total gross floor. And we have around 110 apartments in there. Everything has to be arranged in 4 building units with 111 apartments with 27 apartments, which are made in a wood hybrid construction. So we won the competition for this development site in 2018, and our urban development concept worked with what we call carpet development, with 2 lower, as you can see here and here, and 2 higher buildings. The higher buildings, they are used for gaining a lot of square meters. This development creates an urban proportional connection to the surrounding buildings, as you can see here, which are somehow quite dense, but also with the lower buildings to the open central space, as you can see here. For reasons of efficiency, the higher structures are built in conventional building, like reinforced concrete, steel, glass, thermic isolation layer, as you can see here. And the lower buildings are designed as timber hybrid buildings. The construction of the 2 timber hybrid buildings is very simple. You have a backbone, which sanitary rooms and shafts, which is made on reinforced concrete on site, as you can see here. And attached to that, we have a timber construction, which is, you can see here. The design we had in as construction system has load-bearing exterior walls with a timber panel construction. This was the design system we had in the competition. And on this, we had composite elements with, as you can see here, with wood and concrete slab. Same thing like we have on the HoHo. The executing company changed the construction system for cost reason. We were very surprised that this one is even cheaper than this one. We now have exterior walls in a kind of timber frame construction and ceilings as a timber flat slabs, which are made of 22 centimeters CLT. And we have 10 centimeter extra heavy layering on it for the noise protection. So far, so good. This is a very often tested and tried construction, and you can say it's a very often used construction. But now we had a real problem because the care comes into the play. We chose a synthetic bonded gravel layer for the acoustic effective fill on the CLT panel. This can be installed relatively dry, and it introduces very, very little moisture into the construction site. The constructor, the building company, changed the product and selected a cement bonded filling. this was installed too moistly by the company. So in the classic solid construction system with concrete and brick, this would not be any tragedy, since the mineral materials, concrete and brick, can somehow absorb the moisture in the surface and in the surface and release it to the outside air over the time. In a timber construction, however, the wooden ceiling is protected from moisture by a what we call foil during the construction process. And this foil we keep on as rain cover, as you can see here. We keep on and we build on this foil. So the result is that the excess moisture from the fill is somehow trapped into the layered structure and can only escape selectively to the rising partition walls. This results in a very much higher moisture concentrate on these partition walls. And this moisture concentrate leads to a mold which grow in the upstand area of the partition wall. So this was very smelly and very dirty. And this was the first problem, but we had a second problem as well. During the installation of the top ceiling of the roof structure, the protective foil of the wooden structure was somehow mechanically damaged in several places. I think they have some nails which they put in there. This damage was not discovered right away, and so all the rainwater came into this construction as well. So also we have mold, and what we have is very bad optic on the wooden ceiling. And that is what results out of it. We have to renovate and restore the whole thing. A house was built around the house, and underwater protected conditions, like if you want so indoor, the components were dismantled layer by layer. They clean it, they sterilize it, they dry it, and then they restore it. This is a huge effort, as you can imagine, and a very long way to get finally to this picture, which is of course a rendering, but we are hopefully that in September we will open up with this picture in all our minds. So every construction project can only be successfully implemented by all those who are involved working together. I think the major problem is you have to bring the people together and they have to work together. In timber construction, special care must once again be taken with this collaboration. In the design process, you have always to consider how, by whom, and under what conditions those elements you plan will be assembled together. Everything should be designed this way, so simple as possible, that you provide resistance and tolerance to construction failures. It's not enough just to do your part of the planning well and without errors. This is the basic. Yeah? In timber buildings, everyone involved must always think and act together, and just in this way we can get the best possible result. This collaborative workflow can save you a lot, really a lot of problems. But now we go to the third example for today, and this is a very happy example because tomorrow I have the next meeting where we try to deal with the costs of this project. And the story I will tell you now. Due to the pandemic, the shortage of raw materials, the energy crisis, and the supply problems, the construction prices have become massively more expensive in the recent 2 or 3 years. This is one project of competition project of 2019, and from 2019 to now we have a rise of costs about 30% in Austria. This leads to an evaluation and readjustment of the profitability of every construction project. Depending on the type of project, either the expected return of invest is adjusted, or in the case of subsidized housing, the cost ceiling is defined. There is no other way. The achievement of such a cost ceiling requires, especially in timber construction, flexible design concepts and strategies on how to implement the project in the changed economic environment. This has to be taken into account already in the design phase. So as a final example, I show you this project, which is called the Waldrebengasse, where we are currently going to this process sometimes painfully. This project is a winning developer competition from 2019. I tell you later on what developer competition means in Austria. The site is located in the north east of Vienna. As you remember, the side of the first building is somehow here. The side of the second building I showed you is somehow here. And this is the third building, so they're somehow close together. We have to design 107 rental apartments, a kindergarten, 12 units for assisted living, and 11 units for single parents. And all this together in a wooden building. The surrounding of the building, you can see, is a very heterogeneous area. So you have big supermarkets there, you have commercial centers here like this, and you have small one-family houses and some row houses which coming from the 1970s and 1990s. The size is quite small. So we have a property of about 4,700 square meters. And the thing is, if you have a developer competition, the developer and his team, they apply for a site, and they have to apply in a competition. They bring the best project. They tell the jury what qualities their project have, and for this, they get the chance to buy the site. And the site has a price. And if you are dealing with subsidized houses, the price of the square meter of site must not be more than 188 euros per square meter gross total floor in the case of a subsidized housing. So you can easily calculate that you need gross floor area of 10,400 square meters. And this is really dense in this area. So we have a density of about 2.2. We can do this density by arranging 3 different buildings on the site. And the task was that the building fronts to the street, they meet the proportions of the surrounding buildings somehow. And we create a free space with different qualities and different free urban situations. One thing is that the main part of the free space is somehow lowered, so we can get natural light and natural ventilation into the garage area. And probably you remember what I said about the HoHo project. We learned there that it's very, very hard if you focus on a very early stage on a specific material and a specific building construction, that it's very hard to get an economic optimized offer. So what we did here, we invented the idea of the what we call OPSIS system, open construction system. And this is nothing more or nothing less than the idea that you choose the building materials, you choose the building structures, depending on the local resources you get. So for example, if you take a ceiling, like we have a ceiling here, As material, you can have cross-laminated timber, glued laminated timber. You can have solid wood elements. As a construction, you can have flat ceilings, beam ceilings, ribbed ceilings, or box ceilings. The layering can be either made on site, or it can be made in the factory, so you have a prefab element. And the same thing happens with the wall. You can have the material cross-laminated timber, glued laminated timber, or solid timber, probably like a blockhouse. The construction could be like a solid wood construction, a beam and column construction, frame construction, and a block construction. If you take the core can be made of reinforced concrete, or it could be made of wooden elements. So each material is used the best way to fit the requirements. And this is very, very important, that you have the freedom later on, that you change those materials and you change those construction. Otherwise, you won't get any economic optimized offer. The Waldregengasse competition project is a hybrid building, as you can see here, with the core made of reinforced concrete. Attached to that, there is the wooden structure. The free span is about 7.5 meters, which is a little bit too wide for the economic optimized wood concrete hybrid wood concrete composite element, which would be about 7 meters. So we invented this what we call leverage, where the slab is laying on it, and to that we have a horizontal shift where we can bring some pipes and some wires in there to have more flexibility for the whole building. The construction is a load-bearing exterior element made of 14 centimeter CLT with some wooden, with some non-burnable thermic isolation layer on it. And the outside is a wooden facade, a curtain wall with different vertical planks made of lurch. So this was the project we have at the competition. And the structure and the typological intelligence, as we call this, of the building is very, very simple. We have a load-bearing interior core, as you can see here. We have load-bearing exterior walls, and we have a layer. This is 7.50 meters deep from here to here, where you can bring in every usage very easily. You can change it very easily. And you also can bring in the different sizes and qualities of living apartments in different floors, because you have no load-bearing elements which are somehow cutting this free span. The points of delivery and for bringing away all the waste is situated on the core side, and for this we have even more flexibility to bring in different sizes of apartment and create different qualities, therefore. This is a very important part of the cost intelligence, is the question what to do with garages. In Vienna, we are forced to build many parking spaces for residential buildings. It's one parking space per 100 square meters of living space. So we believe that the mobility behavior will change rapidly in the coming years. This trend has already started. In Vienna, currently, the city has the lowest car ownership rate of all federal capitals in Austria. And the percentage of pedestrian zones and shared mobility zones and pedestrian zones and the things is steadily increasing. So what will we do with all those parking spaces when the cars are no longer needed? Our answer was to create a what we call added value zone. So for lowering the central free space, as you can see here, we can bring daylight and natural ventilation in a part of the garage, which we call added value zone. And if you don't need the parking spaces anymore, you can easily rechange this area with sports and culture and play and recreation. So that the idea is that you can give people the space back the cars took from them. It's a specific of the developer competition that the team of the developer, architect, and experts, whatever is in there, they have to guarantee certain qualities of the project for the jury. And they not even have to guarantee the qualities of the projects, they also have to guarantee the price. And 2019, the guaranteed price for the rental units was a one-time financial contribution of 60 euros per square meters per one square meter of living space. And the rental monthly fee was 7.5 euro per square meters. And this includes the operating cost and the value-added tax. So this was 2019. And we knew it's going to be somehow very tight. And in order to achieve this economic objective, we started a design to cost process. So this means we evaluated every constructions in different variants, as you can see here. This is a sheet of ceiling variants we have. We have wood concrete composite floor on a cantilever beam, as I showed you on the competition, as you can see here. We have a wooden slab made of CLT, just this wooden slab, and we have a wooden slab of CLT with an additional beam, as you can see here, and additional columns. And we calculate all the masses of this, and then we ask a construction company, which was on board since the competition. And here the practice partner recommended that the wood concrete composition, as we had it in the competition, was the most economical variant, and we should therefore take this for the next step, for the next planning step at the permission planning. But then we have the problem with the with the costs. So in September 2019, from there on we had a very volatile market for building materials, and wood was in between, as you can see here. In June 22 was about around 27% more expensive as in the summer of here in 2020. So it's going down, but overall in December, when we started the cost cutting process, we had from the materials wood plus 32% from the beginning, and overall plus 34% from the beginning. And this changes, of course, everything. The general contractor with whom we coordinated the design to cost process could no longer keep the price. So we had to put the project out to tender in the summer 2022, like on this, sorry, in the high price phase, we put this on the market. The estimate price at the time of the competition was about 16 millions. The result of the bid in this phase was the double price, 32 millions. And at this price, it was not possible to realize this project. So therefore, we started a cost-cutting process in December 22. In this process, the entire project is evaluated and scanned for optimization potential. And as I said before, you have to think this on the beginning, otherwise it doesn't work. Otherwise you have a totally different project. And as you can see here, we have a kind of traffic light system with yellow, red and green, which we can do, which we can't do, which we have to check. And we have several points. There are over 50 points right now, which we make like renderings. We make some details to check whatever has to be checked to get an answer if you can do it yes or no. And of course, it should stay a wooden building. So this is just one example of the of our cost-cutting process documents. Tomorrow I have the next meeting about this, and there we discussed about another table. So if you remember, we started with a table at the HoHo and we ended at a table here right now. These tables and of course our BIM model, which is very, very helpful. And of course the variants we already considered in the design process in the beginning helped us somehow to navigate to this very, very hard process. And sadly, we're not there, but we are on the right track. And I'm very, very optimistic that we'll have an economy fitting system in place in some months. So this is our thinking right now. But after all, we are convinced that timber constructions and timber hybrid constructions, they can be implemented very successfully, also under consideration of the current technical, social, legal, and economic developments. But to achieve this, it's necessary to change the perspective of long-used behavior and to work out new qualities with a new and very new approaches. Think differently, act differently, and focus differently. And I hope I have encouraged you to make you want to try this thinking for yourself. Thank you very much.
Okay, Oliver. Thank you very much for this fascinating presentation. Maybe you can open your camera, Oliver. We can see you.
Is it open?
We cannot see your face now.
Okay. Should be open all the time. Sorry.
No problem. And
but it says it's open. Okay.
Okay.
No.
No, we cannot see. We can only see the presentation now.
Okay, so probably I stop the presentation.
Yes, it will be better, I think. Okay, thank you very much for.
Can you see me now?
Yes, we can see you.
Okay.
Thank you very much again. And now maybe our participants has some questions for you. Now I am looking. Is there any question for Oliver presentation? We had three projects, and I would like to say good luck to you for tomorrow.
Oh yeah,
Oliver.
I can use it.
Good luck. Okay, is there any question? Maybe our academicians and students have some questions about the projects, or maybe they can share their feelings, ideas about your design and projects. No, I'm just waiting, but no, there's no question here.
Maybe I can ask them a question.
Okay, Elif Hocam, thank you.
Thank you for the very informative presentation. Mr. Sterl. You are still dealing really with the, even in Middle Europe, this is one of the sustainable targets using ecological materials and so on. Even in that case, it's still somehow a battle. So because of the cost effectiveness, is it correct? This is still like this. Even I have the target, I have to go there. But if it costs too much, then a second thoughts are here.
I would say it's absolutely true what you say, yes. And I would say it the different way. I would say the costs of CO2 are too low. So what we have is the situation that surrounding the environment costs nothing. So what everything is about money. So what they did talk about last year is CO2 about 40 euros per ton. That's nothing. And they had the perspective to have it to 400 euros per ton. But even the 40 euros per ton, they're not in the law right now because they can't get they can't deal with it. And this is a really problem. There are a lot of interests, traffic industry and the concrete industry, and even if we are using wood in Austria, it would be an advantage if we have the CO2 costs because we have the wood in our country. If you bring it probably to Turkey or if you bring it somewhere else, to England, this would be a disadvantage for the wooden structures as well because they would cost a lot more. So, but I think there is no way out of this. Yeah, we have to think differently, and we have to. And this is a political decision. The political decision has to say yes, the environment is. We have to protect it, and everything which hurts the environment must cost a lot of money. Otherwise, we won't work with it. Yeah. You can talk to an investor and tell him he should do something which is more. Which costs more than if he has the chance. Yeah, he won't do it.
Okay, thank you very much. Maybe another point. So, because of the climate change, I can imagine also the ecological environment. That means also the forest itself is under situations somehow. Do you still see a really guaranteed future for the timber because of existing raw material, I mean, in the forests and so on? Is it in danger? Are we going to have some problems in the future, maybe? Because as far as I know, the forests are going higher and higher because this, maybe you can give some information also to our students about this issue.
Yeah, the thing is, as you mentioned correctly, the 9-degree borderline, yeah, which is used for optimal growth for the spruce, which is the main tree in our woods, yeah, and which is the main building material. This is going up. So what happens here is right now we are about in Austria, depending because in the Alps, as you know, worldwide we have a temperature rise about 1.1 degree from 1850 on. In the Alps, it's double, so we have 2.2 degrees. So it's very dramatically here, and the 9-degree borderline is, I think it's about 680 or already 720, depends on the areas. Yeah. So what happens there is that the spruce gets a lot of stress. It is dry, and then you have those little beetles which go into the spruce and they eat the whole bark of the spruce, and this makes the wood and the whole wood is sick. So what happens is this these woods, you can cut them, you can use the wood, but just one time. And then it needs another 40 years, 50 years. And the thing is, the old people, they use the spruce because the spruce is growing very rapidly.
Right.
So it takes it 30 to 40 years, and then you can harvest it. If you take probably another tree, it takes 80 years till you can harvest this. So this is the major problem we are facing right now. And of course, the spruce has optimal it's an optimal building material. If you take another trees, they take up too much moisture. They are changing a little bit too long. They get some shackles in there. So everything is happening here. And to get rid of this, you need some artificial materials like some rubbers or whatever you put in there to glue that together. So you always can have laminated elements. And this could be probably the one of the targets of the futures, that we have to find new wood materials. Because if the climate thing is changing, nobody knows what happens. It could be that different areas which right now have no trees at all, they get the trees. Could be. Nobody knows, but not into the next 40 years, because they need at least 40 years to grow. And this may be a little bit of a problem. If you take just the mass of timber, you have the balance is positive. Yeah, in Austria we have about I think 4 million cubic meter of timber every year, which is
every year. Yeah,
every year. Yeah, but this is not the right timber. This is not only this is not. If you take this part of timber, you probably can use 10% of it. The rest is timber you probably don't can use right now. You have to wait, yeah, because if you have a healthy wood, it takes them 80, 100, 200, 400 years to grow, yeah. And for this, you're absolutely right. We will get a resource problem with wood into the next years.
Thank you very much.
thank you, Elif Hocam. I'm just looking for other questions. Okay, there is no question. Everything is very clear all over. Okay. Okay. I think we can finish this presentation, this meeting tonight. Thank you very much again. And we have a little tradition here in ArchiDesign Timber Talks as Bahçeşehir University Faculty of Architecture and Design. We donate in our guest's name, Oliver. A donation has been made in your name to SAY Foundation.
Okay.
This SAY Foundation is helping underprivileged children for equality in education. So I will send your certification as an email to you as soon as possible. And thank you very much for this interesting and fascinating meeting presentation again. Thanks.
I'm very happy that I could help you, and I'm happy about the donation. Thank you very much, and hope to see you soon. Bye.
Hope to see you. Bye-bye.
Ciao.
See you. Bye.
Thank you. Bye.